Alrighty, Gatekeeper here. We're going to be covering how to build a basic, good working preamplifier. Here's a schematic I drew just for this lesson. Now, I'm not going to sit here and explain exactly everything that's going on with the preamp like I was able to do with the key and circuit, because I'm not going to lie to you, I don't know exactly 100% what each component is doing. I do have a gist of it, how it flows, how the RF comes in. It's sent through this diode. The RF is actually being used itself to turn this transistor on into conduction. Positive voltage mixed with the RF. I understand a gist of it, but I want to understand more of exactly how it's doing it. From my understanding, the transistor itself is being used in the amplification process, but I might, I might just post this video public just to see if someone out there can actually explain and teach me exactly what each component's doing, because that's the kind of builder I am. I want to understand every fragment of every circuit. I want to understand exactly what is going on. Exactly, why is this 470 here? What is it, the value of it for being there? What is the 104 doing? I understand it's doing some sort of filtering, but what exactly is everything doing? I know this 330 is taking a sample of the input coming from your antenna. Well, why is this a 150? Is it letting less of the sample go back to your radio? You know what I'm saying? I want to understand all of this. So I might post this public. Let's move on. Alright. I'm going to just be showing you how to build it in this video. So, First, we're going to get to this point right here. We're going to get to this point right here using these four components. Excuse me. It's late. Alrighty. So let's move this out of the way here. And let's get started. Here's our components right here. I'm going to be building 3 preamps at once, so I'm actually going to be killing 3 birds with 1 stone with this. Alrighty, we're going to grab our 68 kilo ohm, 68,000 ohms. That is our blue, gray, orange, and then a gold for 5%. Refer to my first video for understanding the colors. Big boys race our young girls, but violet generally wins. To understand so you can actually look at a resistor and know what it is. Alright, let's get our 60K, 68K. Alright, let's get our 470 ohm. That is your yellow, purple, brown. Yellow for 4, purple for 7, brown for 1, which means add 1 0, 470, 470. Alright, let's get the 104 cap. It's 104. By the way, just in case you're wondering, 104 means 1 0 and add 4 more zeros to it. So that's 100,000. 100,000 what? Picofarad. This is 100,000 picofarad, which is 0.1 microfarad. A 104. A 103 would be a 10 add 3, which is 10,000. 102, 10 add 2, 1,000. 101, 10 add 1, 1,000. A 10 is a 10. Alrighty, and then grab our glass diode. Our small, tiny glass diode. So that's where we're going to go first. Here we go. Alrighty, like so. Let me sit this right here. Down here so you can see see these components a little better. Excuse me one moment. Hey, we freestyling this. This ain't scripted. But that's why some of them boys, why don't he just wait and smoke a cigarette after he gets done with the video? Shoot, man. I'm in my man cave out here just chilling. Hanging out. Shoot, I ain't gonna change my ways for no video. Oh boy, I just try to keep it real, man. Hey, I'd be smoking a cigarette if I wasn't on the video. I'm a chain smoker when I'm out here working on these components, man. Alrighty. So we put ours, see if we can get this focused in. Alright, we got our 68K and our 470 twisted together just like that. Alrighty. Next we'll be putting the glass diode with a cathode with a stripe face down in that manner right there. Just like that. There you go. Alrighty. We got both our resistors, 68 at the top, 470 on the right. Our glass diode. Trying to remember that off the top of my head. I think it's a 4001, I believe, or hey, I ain't remembered everything, man. Some things I had to look up for reference. 4148, I believe it is. 4148. Don't hold me to it, but I think it's a 4148 glass diode. Alright, now we're going to take our 104. The 104 is going to go into an orientation like this. It's going to hook to the bottom of both leads. It's going to hook at the cathode, the striped end of the diode, and the bottom of the 470. And that orientation right there. Alrighty. This is what we got so far. Just like in that orientation right there. Alright, the next part is the most trickiest part of the whole preamp. Let me show you the diagram again I drew up for you. Alright. Alright, see where it says PNP? That is showing this black transistor, this black three-legged transistor, just in the orientation that it's in now, with the face down. With the front of it face down. Okay. There's the front of it right there, if we can focus in. Using a 4125 PNP. I don't think it's going to focus. Let's see. Yeah, it's focusing, it just isn't showing up. Yeah. Look at it, clean this camera off. But anyway, this is an orientation of being face down. So as you can see, face down, the left leg, face down now, the left leg has to solder here. So this is in this orientation right here. Right here. So it has to solder here. The left leg, the base, which is the middle of it, has to solder here. And the right leg has to solder right here on the right leg of this. It's a little tricky. I still hadn't got the complete hang of it. As I go along, I develop new ways of doing things, easier ways of doing things, trying things new. You ought to see my first few key insert preamps. Hey, if you'd seen a picture of my first preamp, you'd just be like, dang, that's just a globule of components all globbled together in a ball. That's what it looked like. I finally adapted to this style here. But so let's go ahead and do that. I will say some tips. You might want to go ahead and solder all 4 of these legs. I think that is what I'm actually going to go ahead and do. Solder all 4 of these. Tin them up with some solder. Turn the iron on. Then after you do that, very, very, very carefully, you might want to even dip this in some flux that I sent you. Dipped all 3 legs in some flux. And we just dropped it. There it is. Oh. Maybe you want to dip all 3 legs in some flux and just hit it with some solder real quick just to tin up the legs. You do not want this having a cold joint, and you don't want to keep heat on this. Sorry for the gross fingernails. You get that when you're out here messing with these components every day like this. Oh, I think I use my fingernails more than I use tools sometimes. All right, so we're going to attempt to do that now. You hear me say attempt, didn't you? And another quick tip too, you're going to want to kind of try to bend these legs in the orientation they're going to be soldered on. Hey, solder 1 leg at a time, brother. 1 leg at a time. If they made these transistors with really, really long legs, you might be able to just wrap them around and make things a little easier, but they don't. So I'm going to go ahead and do that now. Tin all 4 up, then put them in. Alrighty, let's tin these 4 leads. I am holding the phone with my chin. Let's see how well this works. Like so. Another quick tip, which you probably already know, just in case. I see some people that does not practice this, and they go through a lot of tips and stuff. Tin that cap picking tip every time you put it up now. Put a little piece of solder on it every time you put it up. I mean, there might be some times you doing some Pacific soldering, you have some solder on it. That's fine. But out of good practice, I tin that damn tip every time, brother. And so far, I have never replaced a tip on any of my irons. I've only been doing this for 5 years or so, but I've never replaced any tips so far. Always tin your tip. As you noticed, I heated up the wire, then hit the solder on it and went down, down, up, up. Get that wire hot and just let the solder bond to it. Alrighty. Then we're going to tin the transistor very quickly. Very quickly. Just like that, real quick. I don't know if that got on camera or not, but there we go. Now let's put it on. Alrighty, we managed to pull it off. Like so. Hey, I learned, even though I might have done something 20, 30 times, 40 times, I always learn something new. And I know something that helped me out with putting this on here, I'll share with you. The very first lead I put on was on the right here, which is the right leg with this face down, of course, the transistor face down. And what I done with this leg is I actually wrapped the leg around this right one. I wrapped it around like about one time and just kind of squeezed it with some needle noses to keep it hanging on there. And then once I soldered that leg, then I had something to hold the transistor down while I soldered the other two. So after I got that one on there, it was a piece of cake. There on out, just bent the legs there. I wish this thing would focus in for you, buddy. It might have something to do with the background. Let me hold it right there where the black is. There we go. There we go. It's everything in the background that's kind of messing it up. There we go. There we go. Yeah, I need to start using a solid background in the videos. You can get a better view of it right there. Alright. Now you need to get your 330 picofarad. These are hard to see here. Let's see. Okay, there's the 330. It will say 331K. 3 kilovolt, I believe. 331K. You'd think they would write it with black or writing or something. There we go. Yeah, 3 kilovolt, 331K. Alright, and then you need to grab your 150. They're both the same color. I like to try to keep stuff the same color. I kind of, one of them type of builders that try to make everything look good. Okay, that's another 3. Here we go. Here's the 150s. There we go. The 150 will have 151. 151. That's what that 1 at the end stands for. Add 10 to it. 151. 1 kV, 1 kilovolt. Grab your 330 or 150. Alright, let's bring our schematic back up. As you see, the 330 will be going on the left side of the circuit in between the diode and the 68, which is right here, right there. Sorry about them nasty fingernails. Should have cut them before I done this video. Or at least cleaned them out. I gotta have some fingernails with this, man. Getting wire off, getting wire bent and getting insulation off wire. I use it a lot. My God-given tools. And then the 150 is going to go on the right there. So let's do that right there, and then I'm going to go ahead and get to bed. It's about 5 o'clock. You won't be able to tell in the video, but then we'll come back and put everything on the relay. Alright, let's put the caps on one at a time. Alright, went ahead and put both of them on. Self-explanatory there. Put the 330. The way I done that, by the way, is I cut the lead pretty much almost in half and just wrapped the lead around it. And after you solder them on, then you can bend them into place, make them look good. And after you solder these on, then you can trim the excess of both off the back, because you won't be using them for anything. We will be leaving these on, though. At the moment, we will be using these connections for our relay. We'll be cutting the left there short, but then you'll have your positive, negative connections in the front right here. And then you'll have your RF connections in the back. Let's go ahead and get this soldered. Alrighty, just like that. Alright. Let's go ahead and clip off the excess. Run this black Clip off the excess here. Made that side a little thick. Let me look real close before I cut this off. Make sure I ain't cutting the lead off or anything. All right. All right. There we go. These two will be soldered into the relay. Your positive will be going here, which you'll put this to your positive, your relay. There's no need to be running two wires. I see a lot of people do that with preamps. There's absolutely no reason to be doing that kind of stuff. The relay and the preamp itself run off very, very low amperage. So you can actually just put your positive connection to the preamp to the positive lead of your relay, because both of them will be needing to get positive voltage at the same time. So you'll put the positive lead to the positive lead of the relay, then you'll run your wire to the positive lead of the relay. You put your negative lead to the negative lead of the relay, and then you'll ground your relay. That will be grounded to the board. I also will show you another trick if you tend to have any kind of static. I've noticed on some boxes some boxes will seem to get a little static buildup for some reason in the preamp. I've only had to do this once or twice. If you do notice that, it's very simple. All you do is you put your little small 30 picofarad cap to ground. I'll show you how to do that. It's very simple. You just do that from the output RF, I believe it is. Yeah, the output RF. I'll show you how to do that. No, excuse me. You put that on the actual all the time RF on your jumper. But I'll show you that after we get everything on the relay. I've only had to do that once or twice. Actually, I think I've only had to do that once with a 1x4 I did. Just something about that box. There's a little bit of static buildup. You could hear it. Some people wasn't even worried about it. But I threw it on there, man. It took care of it. And I will thank Mr. X-Force for that one. I learned that from X-Force. I had a little TNT that had one of them on there, and I couldn't figure out why. I took that cat and picker off, and I soon did learn why. Y'all have a good one there. My buddy, have a good one. You know who you are. I don't want to say your name just in case we put this public. I might do that. And when we return, we'll be throwing her on the relay. Here's the relay we'll be using. We'll be throwing her on the relay. We'll need our silicon diode for the relay. Make sure all that static build up from the coil gets shunted to the ground. And that is it. Yep. And we'll wire that bad boy up and be ready for usage. Okay, now it's time to hook our preamp assembly to our relay. Alrighty, I drew this diagram for you because it's always a great idea to actually understand the excuse me, one moment, pull that wire there. You always want to understand how the relay is laid out, what each thing is doing. Hooked up the battery here. Battery's about dead. You always like to understand what everything is going on, and it's a great idea to understand exactly what the relay is doing. And it's a great idea to be able to find the orientation of each relay if you don't know what it is. Most relays will have it on it, but this particular one doesn't, I don't believe. No, it doesn't. So I'm going to show you with a simple continuity meter and a little battery pack I threw together, 3 little 12-volt batteries from the dollar store on how to figure out the orientation of your relay, just for future usage. And as you can see, this is the coil part of the relay. You can usually tell that because it will be a little bit separated from the other leads. So right here on the far end is the coil. A lot of relays do not have polarity. This particular one does, but a lot don't. This right here is your 1N4007 diode, silicone diode, which is right here. That right there is going to allow this relay to last for a long time, to get all that static electricity built up out of the relay shunted to ground. Alrighty, and this right here is your jumper. Excuse me. That is your jumper. That right there, if your radio is, if your preamp is turned off and you are barefoot or whatever, this right here allows the RF to flow through this relay and not through the preamp circuit. So it allows it just to flow through this relay and bypass the preamp circuit on out if you got the preamp off or if you're barefoot. Alrighty. Well, what we're going to do first is we are going to show you how to find the orientation of a relay. If I'm using the right word, forgive me if I'm not, but basically figuring out what your normally open, your normally closed are. This is a double pole, a double throw relay, and listen to me closely. All it is a simple switch. You can look at it as, you know, your regular on and off switch. Okay, you can look at it as this right here is like two on off on switches. Two on off on or on switches. It's kind of like two single pole double throw switches. Meaning right now as the relay sits, it's touching two poles. The two poles that it is touching is this pole and this pole. I drew it right here. Okay, this is the relay right here. Right now the relay is touching this pole right here is touching this pole. On this side, this pole is touching this pole. These are separate. That is why we put our jumper right here. See down here? Our jumper is right here because it is already touching that pole. So when this relay is not actuated and turned on, the RF comes in, goes to this pole, jumps over to this pole, out. Alright? And the dashed line is where this part of the relay, which means this pole, will be touching once it's actuated. So when this relay is turned on, this pole will be touching this pole. This pole will be touching this pole. So when you turn on the relay, this touches that, this touches that, this right here is completely out of circuit. That's why our preamp will be installing on this pole and this pole. So when the relay is turned on, RF flows through the preamp. I'm going to show you how to figure out the orientation of a relay that you're not sure of. Alrighty. Well, hey, let's just put this relay to the side. Let's grab another one. Alright. Use your continuity meter of your DVM, digital voltmeter. You hear the beep? Alright. Hold the phone right here. On one side of the relay, figure out which leads are touching. Okay. So I found which two are touching. Get this focused in here. I'm gonna turn it right here. I found which two are touching. This lead and this lead are touching right now. Okay. Now what I need to figure out is which ones are touching when it's actuated. And then that will let me know the orientation of the relay. Alright. So I'm going to hook this lead right here to the coil. I'm going to go ahead and energize the coil with the battery pack. That's 3 little small 12-volt batteries from the dollar store in parallel. Hook this right here. Hear it clicking, actuating. Alrighty. Now let's figure out which one is touching now. There it is, same orientation of our other relay. Always check each side to make sure the relay is working properly. Trust me, it'll save you a lot of trouble. Alrighty, and it's easy to figure out which one is your main poles that is actually doing the switching. So now, let me unactuate it. When I actuated it, okay, let's go over this again. Before I actuated, this and this one was touching. Alright, when I actuated it, this and this was touching. So this right here is your common, most common. And it's the one that is doing the switching. So that's where you're going to put your supply to. You know, that's where you're going to put your supply to. And in the preamp situation, that's where we're putting our RF to, which is a supply. There you go. That's how you can figure out the orientation of a relay. Now let's get to soldering and put this thing to the relay and install it in the amplifier. Alrighty, we have prepared our relay. Had to use this relay. This right here was a used relay. Try not to use used stuff, but it just all matters about what I'm doing. If I'm doing just a simple project for myself or something like that, I'll use a used relay or something, you know. But this was a used relay. I bent the lead down and it broke off instantly. They'll do that. They will do that. So it's definitely good to use a new relay with a project like this, because you will need to bend these leads, and I'll show you what I'm talking about here soon. So I went ahead and prepared the relay. We put our diode on, the silicon diode, 4007, I believe it is. We got our choke. That's choke, excuse me. Got our jumper on. Alrighty. Let's see if we can get that zoomed in there. There we go. Okay, we got our choke on. So you see there's only 2 sets of leads left. You know, do whatever works best for you. There I go, dropping something again. But what works best for me, these back leads right here where the preamp is hooking up to, right here, I like to bend those leads down and then sit the module here perfectly on and wrap each lead from the cap around it, then solder it. So I'm going to do that now. I'm going to trim the leads right here on these caps and put them on here and solder them. And then we'll be coming back and doing the next 2 connections. Alrighty, here we go. Now, I want you to know one thing that you always need to remember, I have made many mistakes on when I first started off, was actually hooking up the RF connections backwards, which would give you actually when you turn it on, you would get nothing. The 330 side hooks up to the left. Okay. It might not look the neatest right here. I'm just kind of trying to do this quick. I got a lot of things I need to do today, but this would give you just a quick idea. It could look 10 times worse. But the 330 is on the left side, 150 is on the right. Alright, this is very easy. This side is the ground, this side is the power. We'll be wrapping this on this lead of the diode, and we'll be wrapping this They're on the left side of the diode. That's your power connection. That's your ground. Once we do that, all we'll have left to do is the actual RF connections. That will be the two leads we have left. On the left side is the input coming from the antenna. On the right side is the output going to the radio. Okay. And then this side of the relay will go to ground at all times. Then this side of the radio right here, this will come from your switch. You'll have power coming from the power switch. Only when the power switch is turned on. We'll talk about a neat little circuit later that will actually allow you to use your preamp while the amp is turned off. We'll talk about that later. It's called an invert circuit. But with the default way of doing this, you want the power lead to come from the main power switch when it is turned on. So you cannot turn this relay on when the amp is off, because then you'll be trying to transmit RF through this preamp circuit, and you don't want to do that. So we'll put this to the left side, and then that will be hooked up to your preamp switch. And like I said, your preamp switch will be powered by your power switch after it is turned on. Alright, let's go ahead and wrap them around and solder them now. Like so. I can bend it and get it looking all good after I get done. But that is it. All we have left now is to, at this point in time, it's time to install it in the amplifier. We're going to go ahead and do that and try to do that kind of quick as we can. We're eating up a little bit of video storage right now. I might clean this lens on this thing too when I get a chance. But there you go. All we have left is the power connection, and like I said, this right here will be doing two things: power on the relay and the preamp at the same time. There's no need to be running two power wires, and there's no reason to be running two negative wires. That's just a waste of time. There's no reason to. There's absolutely no reason to. They both need to be powered at the same time. You're dealing with a mega small milliamps here, so it's not that big of a deal. Go ahead and use you some 20 gauge hookup wire. Even low as 22 will be fine. I try to stick with about 20 or 22, just whatever I'm feeling. Alright, let's go ahead and set this thing in the amplifier. And first what we'll be doing is hooking up the RF inputs, and that will be coming from the main relay. You will actually see me doing this as if I was actually modifying an amplifier that does not have a preamp, because that's actually what we are doing. So this is actually something that is being done for another customer. So we're killing two birds with one stone here. Actually three, counting those preamps there. I got to put on some relays. I'm going to dig me another relay out. But alrighty, let's go ahead and get this thing installed. Alrighty, we have a 21446. AB bias build I've done about 8 months or so ago. The fellow wants a preamp added to it. Okay, we have already installed the switch already. Okay, I'll go ahead and show this to you since we have already done this already. We have already installed the switch. The way these switches are designed right here, this is the switches he likes to use. The very top here is the ground for the LED. I have a light on here, but the very top is the ground, so just kind of ignore that and just look at the other two. Alright, we have a wire that's coming from the main switch right here. We have a wire coming from the main switch over to the supply end of the preamp switch. So when you turn this switch on, then it sends power to this switch. When the switch is off, this switch does not have power. Okay, very important. Remember that. You don't want this preamp being able to turn on with this switch off. You could fry your preamp that way. Okay, so when this switch is turned on, with your regular switch you'll be using, just connect a wire to that same terminal that you're hooking your LED up to. So that LED comes on when you turn this on, and send it to the supply of this. Okay, and we already have the wire ran from the preamp switch as well, and that's right here. Okay. All right, what we're going to be doing is, you see this jumper on this relay, the main relay. That's the jumper that passes the RF straight through this relay when you're on barefoot mode. Okay, or when you just have the amplifier turned off completely, which is barefoot mode. But that makes it come right here, through this cap right here to here, through this jumper here and on out. Alright, we're going to be removing this jumper, and that's where we're going to tap into the RF. Okay, the right side right here is our antenna. That's our output of the amplifier. Okay, that is what we will be calling the input of our preamp. Okay, that is the input of our preamp, because we are amplifying the signals coming from our antenna. So this is the input of our preamp. So here are our wires. We've already pre-cut our wires to send the RF over to the preamp circuit, to the relay on the preamp. The one wire, after we take this jumper off, one wire will go to this side right here, on over to the 330 picofarad, which is the input of the preamp circuit. Another wire will go from here to the 150, which is the output of the preamp circuit. Then we will hook this power wire up to the power side, and we'll ground everything to the board. This is a very, very tight squeeze, but I think I found a place to put it. Had to do a little bit of dremeling on here, and we might even possibly have to do some insulation to it to make sure this does not touch the side of the case. This is a very tight squeeze, since this is already AB biased and we have a lot of extra stuff in here. Alrighty, so I'm going to go ahead and remove this jumper. And what I'm going to do is remove this jumper and go ahead and mount the relay with some double-sided tape, or you can glue it. I just go with what I feel. This relay for the AB bias circuit, I have it glued. But sometimes I'll use double-sided tape. I'm going to use double-sided tape on this one, just in case we have any problems, so I can take it off and move it. So we'll be back after we take the jumper off, mount it, and I might go ahead and run a wire too. We'll see. Alrighty, we got the preamp assembly along with the relay. We already got that mounted on the board, and we've already removed the jumper from here to here. We're going to take some fingernail polish removal, some acetone, clean that connection up right there just a little, get that flux off there. And then we'll be installing first our two wires to send the RF over to the preamp circuit. Alrighty, we got the preamp assembly along with the relay. We already got that mounted on the board, and we've already removed the jumper from here to here. We're going to take some fingernail polish removal, some acetone, clean that connection up right there just a little, get that flux off there. And then we'll be installing first our two wires to send the RF over to the preamp circuit. Alrighty, we got the two wires installed. As you can see, this wire right here is the input. If you follow this wire all the way, it's kind of hard to follow, but if you follow this wire all the way, it goes all the way to the left side, where the 130 will be in conjunction with it. Let's get this to zoom in. Okay. Alrighty, and then we have the output, which is the wire that is going to be connected to going to the radio. Follow that all the way right here, and it connects to the right connection right here. Alrighty, so we got the RF connections hooked up, cleaned up the with some acetone. Next, we'll be putting this ground to the board, and we'll be hooking up the power wire and then we'll be ready for testing. Alrighty, we got everything hooked up. We went ahead and hooked up the power wire that's coming from the preamp switch. Don't forget, this preamp switch does not need to have power even going to the switch until the main switch is turned on. Okay, don't forget that. If you can turn this switch on with this switch off and turn the preamp on, you do not have these switches hooked up correctly. Now, I will go in just very briefly, but I'm not going to get into any schematics about there is possibilities of running a preamp just like Texas Star, to where you can use the preamp with the amp turned off, but you have to utilize a circuit called an invert circuit. Actually, that's all I'm going to say on the matter. A lot of people don't have a need to do that, just under special reasons. You know, maybe just somebody wants to do something very custom, or somebody actually has a need to run a preamp with the amp off. But we won't get into all that. That's a whole nother lesson right there, a whole nother circuit to add to everything we got here. So the power is hooked up, and we have the ground. Let's get that to focus in. The ground straight to the board. That's the ground for the relay and for the circuit itself. We'll get this flux cleaned off here and go test it out. I had to do a little bit of fabrication so this side of the case would not touch the circuit, but looks like it's going to clear. And there you go. Hope you received a lot out of that. And you now can build your own preamp and install your own preamp. And don't forget, got a problem, you turn the preamp on, you don't hear nothing at all. Always check to make sure you have these wires hooked up correctly. The wire coming from your antenna side needs to go to the 330 on this side. Okay, don't forget that. These transistors have been known to fail quite a bit sometimes. 9 times out of 10, if there's something wrong with a preamp circuit after being used for a while, change this first. I don't know if I did mention, the specific transistor I'm using right here is a 4125. 2M4125. You can use almost any PNP transistor. 2907, 3906, anything like that is fine. This is just what I particularly use myself on this. And there you go. Good luck. Gatekeeper said it. We good and gone. Alrighty, Gatekeeper here. Thought I'd get my pretty face here in the camera. Alright, I'm going to show you the finished product of this preamp install. And I'll also show you the output of this amp by request of the owner of this amp. I will have to say this is one of the, probably if not the best 1446 box that I have done. It just turned out that way. It's AB biased. It's kicking some major booty. That's all I can say. It's pulling very nicely. A lot of 1446 boxes I do that does not have output like this one does. So some of them just turn out that way. That's the name of the game. Alrighty, we are on a dummy load right now. So to let you know the preamp works, what you're going to do is you don't hear nothing now. You see, we're on a dummy load. You don't hear anything. The radio's on. So when I turn the preamp on, you should hear static. That's letting me know the preamp is working properly. If I don't hear anything, it doesn't work. So we're going to turn it on. Okay. Now we're going to turn the preamp on. I'm sure you can hear that static. Let's hold it near it. Hand it back to you. I'm going to turn the preamp off. Alright, preamp on. There we go, working perfectly. Alright, I'm going to do a quick output test on this AB bias 21446 Gatekeeper amp. I have noticed that this LED is not working on this switch. It's hooked up correctly. I guess it's just a defected switch. I know the fella's gonna be upset about that, but hopefully he can just live with it. It's just a defective switch, it appears. Alright, I'll show you what we're going to be driving to this amp. We're on 14.1 volts. Let's turn that down just a little bit. Alright, back up just a little bit. Alright, 13.9 volts, that's fine. Turn that down just a little bit more. Try getting on 13.8. There we go. Show that volts right there. Right there.
What?
You got it? Right here.
Oh, my bad.
It's all good.
Okay, yeah.
Alright. Now I'm going to show you, after I bust the crap out of my mic, what we're driving into it. Right here. Take this light away. 1.6 watt dead key. Do audio. Alright, right there about 21 watts. We'll turn the amp on. 13.8 volts. Variable is all the way down. Oh, check. Oh, check. Alright, 60 watts, 66 watts. I'm going to turn the variable a quarter of a way up. Oh, check. Okay, right there about 100 whiskeys. 100 watts, a quarter of the way up. Halfway up. Oh, Alright, about 180 watts, halfway up. Alright, we're going to do 75%. We're going to do it in notches. No, alright, about 220 to 240. That's usually around max of what my 1446 boxes do. So, you're going to see what I'm talking about. We're going full blast. Here we go. I'm going to show a dead key all the way up first. Alright, we got a 36 watt dead key. Let's let her rip. About 320 watts. Oh, alrighty, about 320 to 330.